When Deborah talked with me and Emily about, hey, we should talk about something that has to do with beauty, I wasn't really sure what to do. And the thing that I came up with was, well, I work in the life sciences. I'm going to try to figure out, is that a beautiful thing? Are the life sciences a beautiful thing? Sounds plausible that they might be, and it makes me feel pretty good about what I do if I'm doing a beautiful thing. A caveat though, so just a little starting out, I work in genomics, so I deal with DNA. And for those of you who sort of slept through biology class, you have a bunch of cells in your body, and then in each cell you have a nucleus, and then you have 23 chromosomes in there. And the chromosomes are just tangled up wads of DNA, which control a lot of things about you. Like how smart you are, how beautiful you are perhaps, and what diseases you might get, things like that. They don't control all of that 100%, but they're a pretty big factor that goes into that. And so I do this I'm a researcher at the Broad, and I'm also at Google, who, aside from running a popular website, actually is interested in trying to use their sort of computing resources in this kind of space. But the big caveat here is that I don't sort of actively engage with beauty in my day job at an explicit, hey, how beautiful can I make this today kind of capacity. So I'm going to sort of entertain some hypotheses about how the life sciences might be beautiful, and I hope that perhaps you guys can sort of add to them or shoot them down later in questions as you see fit. So the first question perhaps is, what is beauty? That's a sort of a good place to start for this kind of stuff. Also, it's a pretty big one for all this in the 10 to 15 minutes that we have here. First thing to say is that, well, there's obviously different kinds of beauty, or there seem to be. Maybe they have something in common. We could look at that. So one big umbrella of beauty is, I'm calling human presets. So things that people probably think are beautiful because of the kind of creature that we are. So we tend to think that this nice lush vegetation surrounding a big body of water in an otherwise barren place might be beautiful because we're thirsty and we have a certain attraction to these kinds of places. Other animals who are scared of predators in those kinds of places, or don't like going outside, like hiding, like roaches, might not find it attractive. And then other people, most people find some other people attractive. Usually it's only humans. We presumably, like baboons, find other baboons attractive, don't find humans attractive. It's probably a human thing that we find the particular humans we do attractive. And then another kind of sort of maybe preset beauty is emotional beauty, perhaps. So maybe we see a painting that really resonates with some kind of emotional state that we have, or that we want to have, or that we miss having in our past, and we find that beautiful for that reason. And that's maybe tied to sort of human emotions and the things that we value as the kinds of creatures we are. So another kind of beauty, at least another kind of umbrella we might lump different sorts of beauty in, is, I'm just going to call it mathematical beauty. And you can think of it as, a lot of people will toss out things like the golden ratio, I'm sure a lot of you have heard of, where artwork that tends to conform to the golden ratio tends to be prettier. It's 1.61, and a lot of, with some other digits, and a lot of things in nature follow this pattern. Nautilus shells, various things follow this pattern. It's used in a lot of artwork, and it's used in a lot of talks about beauty and mathematics and things like that. And then there's fractals, which this is an actual sculpture that an ambitious person did out of stone with fractals. And fractals are another thing that seem to have a very kind of mathematical sense to the beauty that they embody, that maybe this is true, maybe it's not, but it seems a little bit more divorced from the idiosyncrasies of being a human, maybe. And then there's some things that are kind of both. So there's a lot of things in nature that mimic these mathematical formulae, and they kind of are pretty in that sense, and maybe they're also pretty because of other things, like we're attracted to vegetation, we're attracted to vegetables. That is actually a hybrid between a broccoli and cauliflower, which maybe it makes it less attractive knowing that, I don't know. But it is, I think it's a pretty cool looking vegetable. And then as far as the ferns, ferns have a certain sort of mathematical property to them as well. And so I'm not actually going to try to answer this question about what is beauty here. I'm going to sort of let it suffice to say, well, there seem to be different kinds of it, and we're going to leave it at that. But I do want to look a bit more at fractals. So fractals, you've probably all seen fractals in various images that have arrived in your inbox from your friends or something like that. And the defining characteristic of a fractal is that it has self-similarity, which is that as you zoom in on a fractal, it looks the same. As you zoom out, it looks the same. And you keep zooming in, it'll still just look the same. So as you can see here, this is sort of a mathematical rendition of a fern, and but actual ferns do this for 2 or 3 steps. You have the large leaf, and then it's composed of leaflets. Each leaflet has these little sub-leaflets in it that have the same sort of pattern as the other. And so self-similarity is a property of all fractals. This is the Mandelbrot set, which is probably the most famous of the fractals. And if you actually bring it up on your computer and start sort of painting around and looking at it, it can seem like it's all its own little universe of things. And then you zoom in on any given piece, you see the same universe again. And so this is the defining feature of fractals. They're self-similar in a way that's insensitive to scale as you zoom up and down. So what does that have to do with science? So the project here that is sort of the aim of this deck of slides is to try to figure out if the life science is beautiful or not. And so a lot of people have argued, Einstein was a real big fan of arguing that like a lot of scientific theories are beautiful. Perhaps he was pushing his own scientific theories, saying, hey, these are beautiful. But regardless, a lot of people have sort of trodden down this path, and it seems like a really plausible thing, at least to me, that a lot of scientific theories, when you're able to condense a huge amount of data or aspects of the world into some nice, concise set of equations, maybe there's something beautiful about that. But that's not something I'm going to talk about now. So that is probably true in my mind. Maybe it's not. The scientific theories are beautiful, but what about actual practice? What about the actual practice of science, in particular the life sciences? Can we actually claim that the life sciences are a beautiful thing? And like I said earlier, I'd like to believe this if it weren't for the fact that it's like really probably not true. So like a big part about science, right, is you have these machines that you run experiments on. So most of these machines are, I think it's fair to say, fairly ugly, living in ugly situations, and like were built for all of the, subject to all the things that humans, subject to all the same things that everything humans build is subject to. So whims of like capitalism, whims of like who was buying the cheapest part to put in this thing one day, and when is it going to break when you plug it into a different kind of socket than it expects, all this kind of stuff. So it's not particularly where you want to go looking for beauty if you're going to a scientific lab. And then there's the kinds of things that, this is kind of a test for who watched Star Trek and knew about this, so I'm very pleased. So these devices generally don't put out a lot of great data. So you put in a piece of tissue or whatever it is you're trying to study in this thing, and in the case of like genomics sequencers that are trying to read DNA, say, they basically they do some stuff, then they shine a laser at it, and the laser bounces back, and they try to guess based on the color of the laser what the DNA looked like. And they're often wrong, and then eventually the laser ends up frying the DNA. And so like you end up with a lot of things that are not, you end up with a lot of results coming out of these experimental devices, but they're not so amazing. And the way you turn them from this sort of pile of bad data into something that you can do something with is computers and code. And so computers are definitely full of all kinds of toxic materials and things that are like causing bad effects throughout the world, not necessarily an amazing sort of place to look for beauty. And for those who have not written a lot of software code, software engineers do tend to think of some of it as beautiful, maybe, or at least better than other code, and some of it is definitely bad. And it's kind of an analogy with, like, you could see good code as maybe a well-constructed New Yorker article that says exactly what it's going to do, it says it poetically, and it makes sense. And bad code is like a James Joyce novel with every couple words kind of torn out of it, and you could sort of figure it out, but it's not really like an enjoyable experience, perhaps. Apologies to my wife, I know. So given all of this, where can we go with this? Like, so if this is the life sciences as is, can we really try to defend this thesis that the life sciences have a chance of being beautiful? So we're going to try. And one way we might try is by saying, okay, so I've just listed a bunch of ugly things, that's fine. But beautiful things are often made of some ugly things, or at least that sounds plausible. So perhaps you look at individual chips of paint, or little maybe inartful choices for words in a novel, and you're like, that's not really so great. But perhaps it adds up to something on the whole where it's pretty. Some people think this about like human faces and things like that little imperfections actually make it look prettier. So that's plausible enough. But still doesn't tell us, even if that's true, doesn't tell us how the life sciences could be beautiful. It just sort of says, okay, maybe they are, maybe they're not. Another possibility is I'm going to try to see if we can do something with this analogy on fractals. So fractals have this self-similarity, and perhaps this has some intrinsic beauty to it, is one theory for why fractals are beautiful. And then I'm going to try to run this analogy with maybe the life sciences exhibit this same kind of fractal self-similarity. So for example, those same experiments that we had, the same machines down there in the corner that we saw earlier, this is what their results look like. And this is not the exact technology I was describing earlier, but this is what the data looks like as it comes out. And this is, again, sort of shining lights on things and seeing what comes back. And then if you look at hardware, so you have what you have in the bottom left. This is what individual machines often look like, but you zoom out to a different scale and you put them all together, they start to create a particular pattern. So this is an actual Google data center, probably dotted up for the photographer. And then there's the same thing with code. So even code that can be pretty terrible looking code can still actually sometimes do amazing things. And I think it's fair to say that most people in the life sciences would say that the code is terrible, and also that it can do some amazing things. And also that it can even, one path to doing amazing things is creating these visualizations that help people understand the kind of data. And there seems to be some sort of aesthetic quality there. So the hypothesis here is that, okay, maybe the life sciences have this kind of, maybe they have this oscillation between ugly things and beautiful things, ugly things and beautiful things that keep diving down to different levels of, you have an experimental device that makes some data, you have some data that you massage it in some ways using computers that are maybe ugly on their own but beautiful when you put them together, and then code that works at higher levels. And I don't know if this is a particularly plausible thesis or not, but if so, then that is one way that we could actually start to claim that the life sciences might be a beautiful thing. And so the question is, are they? I don't know. And that is the upshot, so don't get disappointed. But there are some things to think about in that. So one is self-similarity what actually makes fractals beautiful? This is a bit broader ranging question, and don't exactly know where we can go with it. Second one is, are there these same sort of scale insensitive oscillations between ugly things and beautiful things, ugly things and beautiful things, and other activities? So I've just sort of picked on the life sciences here because it's what I know. But life science is obviously embedded in larger interactions in the sort of human activities, and art is one of them. And maybe there's this same kind of pattern of activity recurs over and over again. And then a second or a third question, I guess, if I read my numbers, is are these intellectual fractals, like just thinking about an activity that is, you can think about the activity at multiple levels and it kind of repeats at multiple levels. Is that something that we can see as beautiful in the same way in which a fractal that is in front of you, that you see with your eyes, is beautiful? So again, this is not a thing that I plan to sort of definitively answer, because like I said, this is not totally my day job, doing this day in and day out, but I did want to sort of suggest that and see if you guys have any other places you might go with it.